Okay, a radical expression is just any equation that contains a radical or the square root sign. So when you're dealing with radical expressions, you can kind of treat them like a variable, like an x or a y. So anytime you have like variables, you can combine them and add them together. So if you have something like 3 square root of 7 plus 5 square root of 7, since they both have a radical with a 7 inside, that means that you can add them. So you don't add the numbers on the inside, you just add the coefficients. So you would do 3 plus 5, and that's 8, and you would say square root of 7. So you would have 8 square root of 7. Okay, sometimes the numbers inside of the radicals don't match up, and you can't add them unless the numbers inside are the same. So what you can do is, for example, if you have something like square root of 45 plus 2 square root of 5, you can simplify the radical with the 45 first. So you can simplify 45 to square root of 9 times square root of 5, and the square root of 9 is 3. So you have 3 square root of 5 plus 2 square root of 5. Now the radicals have the same number on the inside. They both have 5, and that means you can add the outside numbers. So 3 plus 2 is 5, so you would have 5 square root of 5. The radical stays the same every time. Okay, so if you have something like square root of 28 plus square root of 63, you would have to simplify both radicals before you can add them together. So 28 can be simplified, and if you can't find the perfect square in each number, you can just keep breaking it down factor by factor. So for example, let's say you know that 28 is an even number, so you can divide it by 2, so you can do 2 times 14, and you can break down the 14 to 2 times 7. Then you can find the pair within that number. There's a pair of 2's, which is the same as 2 squared. So if you find the square root of 2 squared, that's just 2. So 28, or square root of 28, can be simplified to 2 square root, and in the inside of the radical, you put the number that's left over. That's all by itself. So it'd be 2 square root of 7. And then you would do the same to the 63. So 63 can be broken down into 9 times 7, and 9 can be broken down into 3 times 3. Since you have a pair of 3's, you can bring it to the outside of the radical, and the 7 that is by itself stays on the inside. So now you have 2 square root of 7 plus 3 square root of 7, and when you add the 2 plus 3, you get 5 square root of 7. Okay. You can also subtract radicals. So if you have square root of 18 minus square root of 50, again, you would simplify both of those first. So 18 can be broken down into 2 times 9, and 9 is just 3 times 3. So since this is a pair, you can put it on the outside of the radical, and the 2 that's by itself stays on the inside. So when you subtract square root of 50, once again, you can simplify that to 25 times 5, or not 5, 2, 25 times 2, and the 25 can be broken down into 5 times 5. So since this is a pair, you can put that on the outside, and the 2 stays on the inside. So you're subtracting these, and what's important to remember is when you subtract a bigger number from a smaller number, you're going to end up with a negative number. What you're really doing is 3 minus 5. So you're going to get negative 2 square root of 2. Okay, sometimes if you have a number on the outside of the parentheses, what you're going to do is you're going to distribute. So you're going to distribute this 3 to the 8 square root of 3 and to the negative 7. So when you're multiplying and you have two numbers on the outside, you only multiply the numbers that are on the inside. So you would do 3 times 8, but you wouldn't do 3 times 3 because this 3 is on the inside of the radical. So 3 times 8 is 24, and the square root of 3 stays the same. And then you're subtracting 3 times 7, which is 21. Now, since this 21 does not have a radical next to it, you can't simplify this any further. 24 square root of 3 minus 21 would be your final answer. You can't subtract them if they don't have the same square root or the same radical attached. Okay, so if you're multiplying by another radical, since it's on the inside, you only multiply it with numbers that are also on the inside. So you would do square root of 6 times 7 and square root of 6 times 3 square root of 3. Now, since the 6 is on the inside and the 7 is on the outside, you can't multiply 6 times 7. What you're going to do is just put the 7 on the outside and say 7 square root of 6. Kind of like if you were doing x times 7, it would just be 7x. This is just 7 square root of 6. Plus 3 times the square root of 3. Since the 6 is on the inside, you don't multiply it with the 3 on the outside. You only multiply it with the 3 on the inside. So the 3 on the outside stays the same, and then you would multiply 6 times 3, which is 18. Okay? However, we are not done yet because we can simplify this further. The 18 can be simplified to 9 times 2, and the 9 can be broken down to 3 times 3. So since you have a pair of 3's, you can bring the 3 to the outside. So on the outside, you would have 3 times 3, and on the inside, you would just have the 2. So you would have 7 square root of 6 plus 3 times 3 square root of 2. And 3 times 3 is 9, so you would have 7 square root of 6 plus 9 square root of 2. Now, these both have radicals, but the numbers on the inside are different, and that means that we can't add these together. So this would be your final answer, 7 square root of 6 plus 9 square root of 2. Okay, 19 square root of 3 plus square root of 12, you would want to break down this 12 first. So you have 2 times 6, and the 6 can be broken down to 2 times 3. Since you have a pair of 2's, you can bring this to the outside and leave the 3 on the inside. So you would have 19 square root of 3 plus 2 square root of 3. Since these both have a 3 on the inside of the radicals, that means you can add the outside numbers. So you only want to add the numbers on the outside, not the ones on the inside. So 19 plus 2 is 21, and then you would say square root of 3. So 9 square root of 2 minus square root of 50, you want to break down the 50 into 25 times 2, and 25 can be broken down into 5 times 5. So you would bring the 5 to the outside and leave the 2 on the inside. So then you have 9 square root of 2 minus 5 square root of 2. Okay, these square root of 2's stay the same. You are only subtracting the numbers on the outside. So 9 minus 5 is 4. So your answer is 4 square root of 2. So 5 square root of 7 plus square root of 28. 28 can be broken down into 4 and 7, and 4 can be broken down into 2 times 2. Since you have a pair of 2's, you can bring this to the outside and keep the 7, the single number, on the inside. So you would have 5 square root of 7 plus 2 square root of 7. And 5 plus 2 is 7, so your answer would be 7 square root of 7. So once again, we want to distribute. You have negative 3 square root of 3 times the sum of square root of 6 plus square root of 3. So we want to distribute this. So remember, when you're multiplying, you can combine the square roots together, but only if they're both on the inside. If you have a number on the outside, it stays on the outside. So negative 3 stays on the outside, and we're going to combine or multiply the 3 and the 6 on the inside. So 3 times 6 is 18. Plus, and then we're going to multiply once again the negative 3 times the square root of 3 over here. So we are going to say negative 3 times the square root of 3 times 3, which is 9. So now we want to simplify both of these. So this 18 can be broken down into 9 times 2, and 9 can be broken down into 3 times 3. So this pair of 3's can go on the outside. So we would multiply the outside number by 3. So negative 3 times 3 is 9, and the 2 stays on the inside. Now we want to simplify the second number. So square root of 9 is just 3, so we would have negative 3 times 3, which is negative 9. So we have 9 square root of 2 minus 9. Since the second number has no radical, that means we can't simplify this any further, and this is your final answer. 8 square root of 3 minus square root of 75, we want to break this down. 75 can be broken down into 25 times 3, and 25 can be broken down into 5 times 5. So since we have a pair of 5's, we can bring it to the outside, and we would have 8 square root of 3 minus 5 square root of 3. And so we want to subtract the numbers that are on the outside. And since we're subtracting, we're going to leave the inside numbers alone. Anytime you're adding and subtracting, you can't combine radicals unless they are the same. So 8 minus 5 is 3, and we would say square root of 3. So 12 square root of 9 minus 4 square root of 9. You can subtract these right off the bat. 12 minus 4 is 8. And you're also multiplying it by the square root of 9. So since we have square root of 9, we can just simplify that to 3. So we would have 8 times 3, and that is 24. So this problem is a little tricky because we have a radical in the denominator of a fraction, and that is not allowed to be there. What further complicates it is that there's an addition sign. So if we have square root of 5 plus 5, we want to get rid of this square root, but we can't do anything without this other 5 attached. So what we need to do is use the sum of squares. So the sum of squares says that when you multiply a minus b times a plus b, you get a squared minus b squared. So this square would get rid of this radical. So since we have square root of 5 plus 5, we want to multiply top and bottom of the fraction by square root of 5 minus 5. Okay, so when we do that, this first number in each one gets squared. So square root of 5 squared is just 5, because 5 times 5 is 25, and the square root of 25 is 5. And we would say minus 5 squared, which is 25. So our new denominator is negative 20. When we take care of our numerator, we want to distribute this 3 across. So we would do 3 times the square root of 5 minus 3 times 5, which is 15. So we would have 3 square root of 5 minus 15 over negative 20. And this would be our final answer. Okay, so once again, we have a radical in the denominator, and it's attached to this minus 3. So since this is a minus sign, we want to multiply it by the inverse of that. So we would multiply top and bottom by square root of 6 plus 3 instead of minus 3. So we would square each number on the bottom and subtract them. So on the denominator, or in the denominator, we would have square root of 6 squared, which is just 6, because the square and the square root cancel out, minus 3 squared, which is 9. In the numerator, we would want to distribute this negative 12. So we would say negative 12 times square root of 6, and we can't combine them because one is on the outside and one is on the inside, minus 12 times 3, which is 36. So now we want to simplify. So 6 minus 9 is negative 3. So we have negative 12 square root of 6 minus 36 over negative 3. And we can simplify this further because both this 12 and this 36 can be divided by 3. So we could say 12 divided by 3 and 36 divided by 3, or negative 3. So negative 12 divided by negative 3 is 4, and 36 divided by 3 is 12. And since these are negatives being divided by another negative, the quotient is going to be positive. So we have 4 square root of 6 plus 12, and this is our final answer. And that is it for operations with radical expressions.